this video, we're going to take a look at polynomials. A monomial is a number, variable, or a product of a number and one or more variables with whole number exponents. So for an example of a monomial, it could be 3, it could be 3x, it could be 3x squared, it could even be 3xyz squared. So those are examples of monomials. Now a polynomial is also a monomial or a sum of monomials. Each monomial is called a term of the polynomial. So looking below, this for example is a polynomial, this is a polynomial, this is also a polynomial. So it's the sum of each monomial. The degree of a polynomial is the greatest degree of its terms. So a polynomial in one variable is in standard form when the exponents of the terms decrease from left to right. So degree, if we look at this polynomial here, the degree is the greatest degree, so it's degree 2. These are also degree 2. Now it's in standard form when the exponents decrease. So for example, we would have like x to the 4th plus 3x to the 3rd minus 2x squared minus 5 or something like that. So notice that the exponents decrease, and so that is in standard form. So let's try these examples, adding polynomials. We're going to find each sum. So when we're adding, we can really just drop the parentheses. So nothing changes here on the right side. So we could just drop it. So let me rewrite it. 3a squared, and then there's no other a squared. So I'm just going to kind of start grouping them together. Then I have a plus 5a, and then I have a plus 8 and a minus 1. So I already started writing it in standard form with the highest degree first and then decreasing. Now let's combine like terms. We need to finish it out. So we have the constants here that we can add together. So this is 3a squared plus 5a, and 8 minus 1 is plus 7. This example here on the right, we have negative x squared plus 5x plus 4 plus 3x squared minus 8x, plus 9. Now I'm going to add this in a different way. So I'm going to add it using what's called the vertical format. And so this is what I'm going to do. I'm going to take one of them and rewrite it underneath the same like term. So I'm going to take this one here, and I'm going to rewrite it on the other side. So negative x squared can go here. 5x can go under the same term. And then plus 4 can go here. Now we're just adding, so that's okay. We can just write it below. And then add down. So 3x squared minus x squared. So remember there's an invisible 1 here. So 3 minus 1 is 2x squared. Negative 8x plus 5x is negative 3x. And 9 plus 4 is a positive 13. So this is done. So try this example. So the horizontal method was this way, the one I did first. I just kind of started rewriting it and just kind of grouping the like terms together. So this is a horizontal method versus this is our vertical method. And each one is good. It just depends on the type of problem you're doing. So try 1 and 2 out. Pause the video. Okay, so if you did the horizontal format here, you could write b plus 4b minus 10 minus 3. So this becomes 5b minus 13. Here, let's see. So I'm going to rewrite this one on the other side. It doesn't matter where you write it, just so you're matching terms here. So I just rewrote it. If there's no sign, this is just adding. So remember, there's an invisible 1 for each of these. So we have 7 plus 1 is 8x squared. Minus 1 minus 1x is a minus 2x, and then minus 2. Now let's subtract polynomials. It's very similar to adding. Now the only thing you need to do is we need to distribute the negative first to make sure that we don't miss that. So I'm going to rewrite that first of all. So this becomes a negative 2y squared, negative 5y becomes a positive 5y, and this becomes a positive 3. Then I'm going to go ahead and rewrite this one here below it. So I'm just going to do the vertical method and then add them together. So now this becomes, that's plus y. So this is negative 2 plus 1 becomes a negative 1y squared, or just negative y squared, plus 5 plus 4y is a 9y, plus 3 plus 2 is a 5. So that is done. So let's try this example here. So again, we're going to distribute this negative, so that becomes a negative 2x squared plus 6. So I'm just going to rewrite everything here. So 5x squared plus 4x minus 1. And then I'll rewrite this negative 2x squared. And the 6 goes here. So make sure you're grouping the like terms together. So there's nothing here, right, on the x, 0x. So 5x squared minus 2x squared is 3x squared plus 4x, and then negative 1 plus 6 is a positive 5. So try this example below. Find each difference using whatever method you would like. Okay, trying this out, you should have gotten p cubed plus 4p squared plus 2p. So notice at the end, negative 3 plus 3 becomes 0, so that goes away. Be careful when you're adding. You need to combine the ones with like terms. That means the variables with the like exponents, so if they're different, they do not combine. And just as a reminder, if you had like 3x plus 2, we can't add them together. They are not like terms. It's the same thing with, say, for instance, 3x plus 5x squared. They're not like terms, so you can't combine them. And then on the right for number 4, so again, being careful with the powers of the variables, we have negative, you distribute the negative, so negative 3k squared, and then this becomes a positive 6. And then negative k plus 5, it stays the same. So you're left with negative 3k squared minus k plus 11. So you can try these down here as well. Find the sum or difference, choosing your method. It's a little more complicated, but see if you can try this one out. So trying this out here, so this you don't have to distribute anything. So I just rewrote this left side underneath the right, and so then you would be left with 2x squared minus xy. So again, most common error here is just forgetting that there is a 1 here in front if there's nothing there. Here you have to distribute the negative, and then you have to be careful because this power is different from the x to the 5th, and so therefore you're left with x to the 5th minus x to the 4th minus 3xy minus 2y squared. The last thing we're going to do is multiply polynomials. So there are several ways to do this. You can use the FOIL method, which is first, outside, inside, last, FOIL. So that would be first, outside, inside, last, or you can do the box method. So for now, I'm just going to do the box method. Kind of helps us organize everything. So then we write b minus 10. It doesn't matter which way it goes. Just remember to bring the sign with it. That is very important. So let's multiply. So we multiply what meets in this box. So 4b times b. So that becomes 4b squared. Then we have 4b times negative 10. That is negative 40b. Then we have negative 3 times b is negative 3b. Then we have negative 3 times negative 10 is a positive 30. Now what's nice about the box method as well is that you can see we want to combine like terms, and so we notice here that those are like terms. And it's not always a diagonal, but a lot of times it is. So just be careful with that. In this case, it is like terms. So when we write this out, this is going to be 4b squared because we want to write it in standard form. And then we have negative 40 minus 3, that's a negative 43b. And then if there's no sign here, a plus 30. So that is the answer. Now with something like number 2, we can do a 2 by 3 or 3 by 2, whichever you would like to do. So I'm going to do a 2 by 3. So it can only fit one way, 7x squared minus x squared minus x, and minus 2. Then we multiply through. So this becomes 7x to the 4th. Remember, we're multiplying, so you add the exponents. Then we have negative 7x cubed, and then negative 14x squared. So negative x times x squared, that's a negative x cubed. Negative x times negative x is a positive x squared. Negative 2 times negative x is a positive 2x. Then we can combine like terms, so these are alike, and these are alike here. And then so our final answer, 7x to the fourth minus 8x cubed minus 13x squared plus 2x. So try out this next example here. And then also number 4 is a little more challenging. That's going to be a 3 by 3, but it's good practice. But if you can at least do number 3 and maybe try number 4. So hopefully you tried this out. For number 3, you should have gotten 10y, 10x to the fourth plus 8x cubed minus 32x squared minus 24x plus 6. So the only ones you can combine is the x squareds here. For this one, hopefully you tried this out. And it was a good practice in writing it in standard form. So the only ones that combined were the fifth powers. And so you should have gotten 2y to the 7th minus 5y to the 6th plus 5y to the 5th minus 20y to the 4th minus 12y squared plus 4y squared minus 10y minus 6.